advanced proving strategies. We think back to our very first strategy that we learned was change everything to sine and cos. And then once you've changed everything to sine and cos and approved, let's see if we can get a single fraction on both sides. But there are going to be some times when you do that, you get stuck. This is one of those examples. You go, okay, I'll change everything to sine and cos, and you look at it, it's already in sine and cos. So you're like, okay, well, I'll make both sides a single fraction. And you look at it, and this is already a single fraction, and this is already a single fraction. So we are technically, for all of our main strategies, all the work's already done, and we're not even close to proving. So we are stuck. And when you get stuck, there are two main things that you need, or two main strategies that are going to help you get unstuck. One of them is factoring. And unfortunately, this question, there's nothing you can factor. And the other one is one that I call build the other side. There's a fancy math word for this one, and it's so fancy that people don't remember it, nor know what it means, so then they can't do the strategy because they can't remember the word. So I found that if I use build the other side as a strategy, it's easier to remember. It's kind of intuitive in what they're telling you to do, and you remember the strategy better. So, what is the build the other side strategy? Well, if you get stuck, both sides are single fractions, nothing factors, nothing's the same, well, you decide, I'm going to make something the same. Maybe I'll make my numerators the same. Maybe I'll, even more common, because you're used to making denominators the same, maybe I'll make my denominators the same. Right now, the denominator on the left side is sine theta. The denominator on the right side is 1 plus cos theta. So in order to make my denominators the same, this side is missing sine. And in order to make this side have a common denominator, this side is missing 1 plus cos theta. And so what we're doing is we're building the two sides up so that their denominators are the same. And we're hopeful that if we at least make something the same, maybe something else will jump out at us to help us solve the rest of this problem. So now, if I write my denominator, I'm not even going to multiply it out. I'm just going to leave it factored on this side and same thing on this side. Now, my denominators are the same. Close that bracket. On the right-hand side, sine theta times sine theta, that would be sine squared theta. And on the left-hand side, I have 1 plus cos theta multiplied by 1 minus cos theta. And one of the skills you need to really develop in this unit is noticing when you have a difference of squares. Remember with the difference of squares, when you factor it, you get the same thing, but one is plus and one is minus. Okay? This is a difference of squares, so when we multiply it out, I would get 1 minus cos squared theta. The mathematical word for these things that are differences of squares, they're called conjugates. And that's the math word I think you would not remember. If I said, define for me, before I told you that, what is a conjugate in math? I bet you I say, I'm going to ask someone to define what conjugate is in math. I would look up, and nobody's eyes would be looking at me. Everybody would be like, I'm going to look somewhere else. Because nobody would want to describe that, because you wouldn't remember. A conjugate in math is a binomial that's identical, except the sign in between is different. One's plus, one's minus. When you multiply by a conjugate, you always get a difference of squares. But because the word conjugate is hard to remember, it's like, oh, use the strategy, multiply by a conjugate. Your brain will be like, I'm supposed to use a strategy, but I don't know what it's called, and I don't know what it means, so I don't know how to do it. So I changed the strategy name to build the other side, because that's what you're doing. Let's make our denominators the same. That's easy enough. And now, my denominators are the same. Hopefully, there's something in my numerators I can do. and this is one of our big ideas, right? You can take sine squared plus cos squared equals 1, and with one mental math manipulation, move the cos squared to the other side. So 1 minus cos squared is equal to sine squared. You don't have to show any more work than that. And we have our proof. So the build the other side strategy and factoring you use when you get stuck, and they can often help you get unstuck quite easily. This one for sure was easy. Recognizing when are the best places to use the build the other side. If you look at your original question, and along the diagonals, you have conjugates. In other words, a difference of squares kind of idea. See how I have a 1 minus cos theta and a 1 plus cos theta on the diagonal there? And on the other diagonal, I have sine theta. If the two diagonals seem to make one of these three, sine squared plus cos squared equals 1, or tan squared plus 1 equals secant squared, or cotangent squared theta plus 1 equals cosecant squared theta, that might be a hint that the build the other side strategy would be really quick. Okay? But it should be, these should be strategies you don't do at the beginning. The build the other side strategy, when used in the wrong place, makes your side bigger with more things. And if you have more things, sometimes that's harder to simplify. So it's not necessarily a strategy you're using right away, but only a strategy you're using once you get stuck. All right, second one. First of all, there is a common mistake that is done on this one when changing the right-hand side to 1 over sine squared. Okay, cosecant squared theta is 1 over sine squared theta. What I want you to do is think about, what does that 2 do? What would I get if I change it to sine squared and simplify that side? What would I get? And I want you to do that on your own first, because if you're going to make the mistake, whether I show you the right way or not, you will make it again on the test, unless you've been exposed to making that mistake to yourself. So I want you to simplify that side, then I'll show you the mistake, and if you made it, then hopefully you're not going to make it again when we get to the quiz or test. So just the left-hand side, change the cosecant squared to 1 over sine squared, simplify things, see what you get. I'm going to come around and check what people have there. And then simplify. Put it together so it's a single fraction. And if you're feeling like I'm unsure what to do, think of it like in a test, you would do something. What would you do? Write it down. Because you will do the same thing on a test that you're doing right now, and so you want to find out if you're making that mistake or not. Now let's see what you do with that too. I'm not going to tell you. I'm trying to find out. Find out. Have patience. One of these simplifications is correct, and one of them is wrong. Okay? It's how we deal with the 2. Does the 2 make a difference? Yeah. So, should this be 1 over 2 sine squared theta, or should this be 2 over sine squared theta? Some of you have one, some of you have the other one. If we break it down, and we do it step by step, cosecant squared is 1 over sine squared. And if we're multiplying fractions, that 2 is a 2 over 1, okay? And multiply the tops, multiply the bottoms. It should be that the 2 stays in your numerator, and this one is wrong, okay? But we will get tempted to skip this step in the middle and just write something as a single fraction right away. And when you're tempted to do that, sometimes you'll be tempted to pull the 2 down to the bottom as well. That 2 will stay in our numerator. So if you made the mistake, pay attention to it right now, because I have every right to be angry with you if you make it again on the text. Yes?
So if you skip the middle step, will it be wrong?
No, if you skip the middle step and just went from here to here, that's fine. Just when you skip the step, sometimes you're going to be tempted to bring the 2 down. So it's not, I would actually say, it's not bad to write that step, just to remind yourself, hey, that 2 needs to stay in my numerator. Now, on the other side, we don't have a single fraction. So our number 1 strategy is to get a single fraction on both sides, and our denominators aren't the same. So we need to have a common denominator, meaning this one needs to be multiplied by 1 plus cos theta and 1 plus cos theta. And this one multiplied by 1 minus cos theta and 1 minus cos theta. That will give me a common denominator. You might notice that it's a difference of squares. So as a difference of squares, I can multiply it out, and I would get 1 minus cos squared theta. On the top, I would have 1 plus cos theta plus 1 minus cos theta. If you're looking at your like terms, the cos theta minus cos theta would be 0. You're just left with 1 plus 1. So now I have a 2 in my numerator, and 1 minus cos squared theta. That's our big idea. We can change that directly to sine squared theta. And we are done. So what I'd like you to do is I'd like you to turn to page 620, and we'll write down these strategies, but we're going to kind of categorize them a little bit. Right, the number 1 strategy, right, are these 2 together. Changing things to sine and cosine, combining fractions, so writing both sides as a single fraction, that's going to be the number 1 strategy. Usually the first thing that you're going to try. And most of the time, that's enough. That's going to get you able to solve the majority of your proofs. But then I mentioned sometimes we're going to get stuck. So I am going to put an S for stuck. There's 2 strategies to get yourself out of being stuck. One of them is factoring. So always be on the lookout for differences of squares. And the other is build the other side, which is multiplying by the conjugate. So multiply by 1, the conjugate is the same as building the other side. Those are ones that you're going to use when you get stuck. Now we've also seen that sometimes changing to sine and cos works, but it's not the fastest proof. So if you are looking at the equation first, look at the other side, see if it has any hints. Sometimes it will give you a hint that you should use one of the Pythagorean identities, right? Especially if you see a 1 in the equation, it's probably that you'll have to use one of those sine squared plus cos squared theta equals 1, or tan squared theta plus 1 equals secant squared theta. Those ones can sometimes be quicker than using the number 1 strategy. Number 1 strategy would probably still work, just be longer, but if you're aware of what's on the other side and think about it a little bit, sometimes there's hints.